By 1995, the Yellowstone River was eroding its own banks. The elk herds were 19,000 strong and eating everything that grew near the water. The aspen stands were failing. The willows were gone. The beavers had left decades earlier because the willows they needed to survive had been grazed into nothing. The whole northern range was collapsing in slow motion, and nobody had a fix that worked. Then the federal government spent $3 million doing something ranchers called ecological vandalism, something livestock associations fought in court, and something nearly every county commissioner within 200 miles of the park formally opposed. They drove 14 wolves across the Canadian border in wooden crates and released them into that dying landscape. What followed was not what the ranchers predicted. It was not fully what the biologists predicted either. Those 14 animals set off a chain of changes so far-reaching that economists who later tried to calculate the total value of what they rebuilt arrived at a number that stunned the scientists who had been watching it happen in real time. $94 billion, not over a century, as a documented return on an investment that cost less than a single mile of interstate highway. To understand how 14 wolves produced that number, you have to understand what they were walking into, and how long it had taken to get that broken. The wolves of Yellowstone were not removed in a single dramatic event. They were systematically eliminated over the course of several decades, animal by animal, pack by pack, under the authority of federal predator control programs that began operating around the turn of the 20th century. The logic was straightforward. Wolves killed livestock. Livestock meant money. The federal government employed hunters and trappers whose specific job was to locate and kill every wolf they could find across the American West. They were efficient. By 1926, the last documented wolf pack in Yellowstone had been killed. The extermination was considered a management success. Nobody at the time thought to ask what role the wolves had been playing in the ecosystem, because the scientific framework for even thinking about that question barely existed. The idea that removing one predator could restructure a river was not something anyone was in a position to predict. So the wolves disappeared, and for a while, everything seemed fine. The consequences did not announce themselves immediately. They accumulated slowly, across decades, in ways that were easy to misread as normal variation. The elk population began to grow. Without wolves hunting them, the herds expanded steadily through the middle of the 20th century. By the early 1990s, the northern range of Yellowstone was supporting roughly 19,000 elk, a density impossible in the presence of a functioning predator population. Those elk grazed with the abandon that large herbivores display when nothing is hunting them. They stood in river valleys for hours, cropping willows and aspens down to the waterline. The result, visible in aerial photographs taken across the 1970s and 1980s, was a landscape being grazed into structural collapse. Aspen stands that had persisted for centuries were failing to regenerate. Saplings that sprouted in spring were eaten before autumn. The cottonwoods along the riverbanks were declining. Willows that stabilized stream edges were being consumed faster than they could regrow. The rivers themselves were beginning to change shape, eroding laterally as the root systems that held their banks together slowly disappeared. Stream channels that had been narrow and defined were widening into braided shallows that dried out faster in summer and flooded harder in spring. The park looked beautiful to tourists. It was dying at its foundation. The debate over whether to reintroduce wolves to Yellowstone had been active in conservation circles since at least the 1960s. It took the better part of 3 decades for that debate to reach a policy decision, and even then, it required an act of Congress, an Endangered Species Act listing, and a formal environmental impact statement. The opposition was intense and genuine. Ranchers operating adjacent to the park's boundaries had legitimate fears. Wolves do not respect park boundaries. A calf on a grazing allotment is not a wolf's idea of off-limits territory. The federal government's compromise involved a compensation program for livestock losses attributed to wolves. It satisfied almost no one. The wolves selected were identified from Alberta and British Columbia, animals that hunted the same prey species they would encounter in Yellowstone, that had no history of livestock depredation, and that represented sufficient genetic diversity to give a founding population a realistic chance. In January of 1995, the first shipment crossed the border. 14 animals. They were held in acclimatization pens inside the park for several weeks before the pen doors were opened. Nobody knew whether they would stay. They stayed. And within weeks of the first free-ranging movements, something began to shift in the landscape around them, though it would take years before anyone fully understood what they were witnessing. The mechanism was not simply that wolves killed elk. That part was expected. The mechanism was that wolves changed how elk used space, and that change in behavior had consequences that radiated through the ecosystem in directions nobody had fully mapped. When wolves are present, elk avoid specific landscape features that create hunting advantages for predators. Valleys with limited exit routes, riverbanks hemmed in by steep terrain, dense riparian vegetation where a wolf can close the distance before an elk can accelerate. Ecologists eventually gave this phenomenon a name, the landscape of fear, and it turned out to be one of the most consequential ecological forces in the park. The elk were still in Yellowstone. Their numbers dropped, but the drop alone did not explain what happened next. What happened next was that the places where elk had spent the most time, the valley floors, the stream corridors, the aspen groves along rivers, suddenly experienced dramatically reduced grazing pressure. Not because the elk were gone, because the elk were nervous. The willows came back first, in the valleys where wolves were most consistently present, then the aspens, then the cottonwoods along the river margins. This recovery was geographically specific, appearing first and most dramatically in precisely the areas where wolf activity was highest, which was itself a kind of experimental proof. The vegetation was recovering not uniformly, but in direct correspondence to where the wolves were hunting. By the late 1990s, aerial surveys were documenting new tree growth in river corridors that had been bare for decades. The root systems of those new trees were beginning to stabilize the banks of streams that had been widening and shallowing for years. The rivers were changing, not metaphorically, physically. The channels were narrowing. The banks were becoming more defined. Sediment loads in some tributaries declined measurably as root systems took hold. Hydrologists were producing papers with conclusions that would have seemed implausible to anyone outside the discipline. Wolves were reshaping the rivers. The mechanism was not complicated, it was roots, and the absence of the animals that had been preventing roots from establishing for 70 years. The beaver colonies arrived as a consequence that had been predicted in theory but was still striking in practice. Beavers require willows. Without willows, beavers cannot build, cannot feed through winter, cannot maintain the lodges and dams that define their ecological function. By the mid-1990s, Yellowstone had exactly one documented beaver colony. As the willows recovered, beavers followed. By 2012, 9 colonies were active. Each one added infrastructure to the watershed, dams that slowed water flow, raised water tables, and created shallow ponded areas that became amphibian breeding habitat, insect habitat, and waterfowl feeding grounds. The dams stored water through summer, sustaining tributary flows that in previous decades had run dry by August. They captured sediment during spring floods, building up the stream bed rather than allowing it to incise deeper into the valley floor. The beavers were not intentionally engineering a more functional watershed. They were doing exactly what beavers do. The difference was that the conditions that had made the watershed inhospitable to them for decades had been removed, not by human intervention, but by wolves. The effects spread beyond the rivers. Grizzly bears experienced measurable nutritional improvements that biologists traced back, through several biological links, to the wolves. Wolf-killed elk carcasses became a substantial food source for bears in early spring when other food sources are still scarce and limited. Scavenging on wolf kills allowed bears to recover body condition faster after hibernation, improving reproductive success in females. The recovery of berry-producing shrubs across areas where elk grazing had declined provided bears with improved late-summer food, critical for building fat reserves before denning. The connection was indirect but entirely real and traceable. Wolves reduced elk grazing pressure. Reduced grazing pressure allowed berry shrubs to recover. Recovering shrubs fed bears. The food web was not a diagram in a textbook. It was a living system that repaired itself once the apex was restored. The coyotes did not benefit. In the absence of wolves for 7 decades, coyotes had functionally filled the top predator niche across much of Yellowstone's interior. When the wolves returned, they drove coyotes out of their territories and killed them outright. Populations in areas of high wolf activity dropped by roughly half. With fewer coyotes hunting them, populations of small mammals, ground squirrels, mice, and voles increased measurably in those same areas. Those recoveries supported hawks, owls, badgers, weasels, and foxes that had been operating at suppressed densities for decades. The predator removal that had seemed complete in 1926 had distorted every tier of the food web in ways that were not visible until the top was restored and the distortions began to correct themselves. One species missing, and everything downstream of that absence had been running wrong for decades. The economic accounting came later, and the methodology was contested, as it always is when ecologists translate biological processes into dollar figures. But the logic was not complicated. Healthy riparian vegetation reduces stream bank erosion. Reduced erosion reduces sediment loading in downstream water systems. Functioning beaver wetlands buffer drought impacts and reduce flood peaks, with measurable economic value in reduced infrastructure damage downstream. Recovering forests sequester carbon at rates that represent substantial economic benefit. The tourism dimension was more direct. Wolf watching in Yellowstone generates an estimated $35 million annually in direct spending in gateway communities, supporting local economies in ways the park's original wildlife inventory never produced. The cumulative modeling that arrived at $94 billion incorporated all of these dimensions across a multi-decade projection. A predator reintroduction program that cost $3 million in 1995 triggered ecological recovery whose economic value dwarfs the entire federal budget for Yellowstone's annual operations. The story has not been without complications. Wolves crossed park boundaries regularly, as anyone with knowledge of wolf territory size would have predicted. Federal protections did not follow them. Livestock depredation incidents occurred. Compensation programs helped, but did not fully resolve the conflict between ranching families operating adjacent to federal land and a predator that moved freely onto their property. Legal battles over wolf management continued for years, with delisting and relisting events changing the wolves' legal status multiple times. By 2012, wolves outside park boundaries in several surrounding states were subject to regulated hunting seasons. Wolf 832F, a female who led the Lamar Canyon Pack and was wearing 3 GPS collars because so many independent research projects were tracking her, was legally shot just outside the park's northern boundary in late 2012. Her death focused international attention on what happens at the edge between protected and unprotected land, a question that will persist as long as wolves and cattle share a landscape. What research on pack dynamics following losses like that revealed was something unexpected. Wolf packs are more resilient to leadership loss than biologists had assumed. When alpha animals die, packs reorganize, adapt, and continue. The Druid Peak Pack, which grew to 37 members at its peak, became the most intensively studied wolf pack in the world, not only because of its size, but because of the behavioral complexity it displayed. The wolf researchers designated 21M became notable in the scientific literature for behavior that complicated standard models of wolf social structure. He never killed defeated rivals. He adopted orphaned pups from other packs, and he remained bonded with the same female for the duration of her life. Biologists who had spent careers resisting anthropomorphic interpretation of animal behavior found themselves writing carefully qualified sentences about what they were observing. The Yellowstone reintroduction changed conservation biology not just by demonstrating that trophic cascades are real, but by producing decades of data on a single large ecosystem that no other study site could match. That data has informed wolf reintroduction proposals on multiple continents. In Scotland, where red deer have driven woodland recovery off course in ways that parallel what happened in Yellowstone before 1995, serious governmental discussion of wolf reintroduction is now underway, informed explicitly by the Yellowstone record. The cascade that started in a Wyoming river valley in 1995 has become a reference point for how ecosystems function at the largest scales. There are approximately 520 wolves in the greater Yellowstone ecosystem today. They hunt elk through terrain their predecessors shaped over millennia, and their presence has restructured that terrain in ways that will persist for centuries. The rivers they have indirectly stabilized will carry less sediment to reservoirs decades from now. The aspen stands recovering along corridors they patrol will sequester carbon for the rest of this century. The beaver dams built in the wake of willow recovery they enabled will continue moderating stream hydrology through droughts that have not yet happened. None of this was what the ranchers in 1994 were predicting. None of it was what the livestock associations that filed suit against the reintroduction program were anticipating. And while the full extent of the cascade was not something even the biologists who designed the program could have fully predicted in advance, the underlying principle they were acting on was correct. The system had been broken by a subtraction, and the way to fix a system broken by subtraction is to put back what was removed. The wolves did not need to be told what to do with a landscape that had been missing them for 70 years. They already knew. They had been doing it for 10,000 years before anyone thought to stop them. If the logic of how ecosystems repair themselves when the missing pieces are restored is the kind of thing that holds your attention, subscribe, and we'll keep following that thread wherever it leads.